All right, welcome back. We're here for section 5.2. And in previous lesson, we found that we don't really reflect that parabola over the y-axis because it's kind of symmetric, and it really results in the same thing. So we know that there's symmetry involved with that. So we have this thing that cuts it in half. We call that the axis of symmetry. And if it's in this form, where you have a times x minus h squared plus k, x equals h is that axis of symmetry because that is where the vertex is. Remember how we move that? That tells you whether you move it right or left, and then k is if you move it up or down. The x value there, which is h, actually gives you the vertical line that cuts right through the vertex and cuts that in half and has that symmetry. All right, so if we're looking for the axis of symmetry for this graph, we really kind of just pay attention to this part right here. So again, what that would do is move it left 5. So the axis of symmetry is just really going to be x equals negative 5 is what we're going to see there for that. So again, that's kind of a slick way of doing it if it's in that form. Gives you the axis of symmetry when it's there. All right, here's some other properties that we can figure out. Sometimes it's not in that form. Sometimes it's in what we call standard form. And that's what's right here. And these coefficients tell us quite a bit. A, the number in front of the x squared, if it's positive, makes it a smiley face. If it's negative, it makes it a frowny face. It makes it go downward. The axis of symmetry we can simply find, in this case, if we take the opposite of b divided by 2a. And then, of course, that's the x value. We could just take that in for x into that equation, and that would tell us the y value. The y-intercept is always just the c value right up there, whatever that is, because if you put a 0 in for x, that eliminates the ax squared and the bx term. So that's going to be the y-intercept. And again, these are some nice rules of things that you can do. You can also graph it using Desmos, which is always a great tool to use whenever graphing things. All right, so again, remember that. All right, so here we go. We have a problem here. All right, determine if the graph moves upward or downward. And again, that all depends on this number right here. Again, that's positive, so we would say that it opens upward. Okay, now the axis of symmetry is found by taking the opposite of b. All right, well, b is negative 4, so that's going to be positive 4, all over 2a. Well, that's 4, so again, our axis of symmetry is going to be 1. Now, that's where we go through the vertex. So that is the x-coordinate of the vertex. That's 1. And so what we can do is put that back into here. What we can do is take 2 times 1 squared minus 4 times 1 plus 5. Well, that's going to be 2. If we go minus 4, it's negative 2 plus 5. That's going to be 3. That's what we get there. So that's going to be what the vertex is. The vertex, the x-coordinate is always the same as the axis of symmetry because it goes right through it. Okay, so kind of slick that we have here. We did that. And then, of course, the y-intercept, well, that's just going to be this one right here. That's going to just be y equals 5. Sorry about that. And that's what we have there. Okay, so we can always use those little formulas to find that. Now, the other part, as we can do, let's do another one, but this time let's actually use Desmos to solve what that is. Okay, we've got those, yeah, fill those in. All right, you can graph the function. That's pretty easy. All right, we got it with all those different things. Okay, now this time, let's actually go to Desmos. So we have negative x squared minus 2x plus 3. So here we go. Let's negative x squared. Let's get negative. Let's see if we're going to try to get negative x squared. I wonder if we can get that. I got to get that up there. Let's see. We got. Now let me get to my keyboard here. All right. Let's see what we got here. Negative. Let's go right up here. Negative x squared. There we go. Negative x squared wasn't letting me get to there. Let's see. Minus 2x plus 3. All right. Let me just make sure that I have that right. Yeah, negative x squared minus 2x. So there we go. So now we got all these wonderful things going on with Desmos right now. So again, some of the questions, obviously, if it opens upward or downward, it's obviously downward. As we kind of take a look here, we can certainly find the vertex. Let's close that. You can actually find the vertex just by touching it, negative 1, 4. Well, therefore, the axis of symmetry is that line that goes right through there. It's x equals -1. So actually, it's really slick to find that. Now, to find the y-intercept, we know that it's 3 just by looking at the equation, but we can also just touch it and figure out that that's the y-intercept as well. So a couple different ways of being able to find those things, either by using the kind of rules that they're there, or obviously by using Desmos and graphing is actually a really great way of finding those different things that we have. And we did all that already, so there we go. All right, now a couple things that we should know is that if the parabola opens upward, the vertex is the minimum value, and it's the y value that we talk about. And with parabolas, as we talk about the domain, those are the input values. You can put anything you want in there; it's all real numbers. For the range, though, it's the outputs, it's the y's. Well, if you kind of take a look at this, you kind of know that, well, you're never going to go below that point right there. So that k value, that y value, is in this case the minimum value. It'll never get any lower. It goes on indefinitely, so there's no maximum in this case. Now, there is a maximum over here where you have the parabola open downward. This, again, you can put any number in, all reals for domain, but for the range, it's all numbers. This is a maximum. All y's have to be less than or equal to that k value when you do that. So again, graphing it is always a good way to visualize what's going on when dealing with those. Okay, so find the minimum or the maximum value and then state the domain. Okay, so we kind of want to figure this out. So I think what I would do, let's go back to Desmos, -3x squared. Let's clear that out of there. See if I can get my screen up there again. Let's see if we can get that. There we go. -3x squared. You go back and see, plus 2x minus 4. Okay. Plus 2x minus 4. Okay, so there's our graph right there. I'll hide that away for right now. All right, so now we want to kind of figure out, well, we obviously have a maximum value, and it's going to occur if we touch it right there. Well, it occurs right there at -3.667, -3 2/3. That's the maximum of that parabola. So by just graphing it, we can see. Now remember, it's the y value. It's the y value that we have there. Okay, so again, you can do that computing as well. It just makes sense to graph it, same thing that you get here.